All right, today we're going to dig into one of the most fundamental, most powerful processes for purifying our water, sedimentation. It sounds kind of technical, but really it's a method that uses the single most reliable force in the entire universe to take that first absolutely crucial step toward getting us clean, safe drinking water. So just picture this for a second. You've got a massive reservoir, a river, some huge source of raw water that needs to be treated for a whole city. And it is just full of dirt, silt, all sorts of gunk. I mean, where do you even begin with a problem on that scale?
You start with gravity. Yep, that's it. Before you get into any complex chemistry or fancy high-tech filters, we just let the oldest force in the playbook do all the heavy lifting. It's so simple, it's brilliant, and it is incredibly effective.
So the main goal here with sedimentation is to remove what we call suspended particles. These are all those tiny little bits of physical stuff, dirt, silt, clay, that are just floating around, making the water all cloudy. This entire process is engineered to do one thing: get them out. Let's get a closer look at our target here, suspended solids. Now, the key thing to remember is they're not dissolved in the water like sugar, they're just hanging out, being carried along for the ride. And getting them out is the first major battle in water purification. It's a critical one, because once they're gone, every other step in the process gets a whole lot easier. So how do we actually put gravity to work on this massive scale? Well, the answer is a purpose-built piece of equipment. It's called a settling basin, or more often, a clarifier. Now, clarifiers generally come in two main flavors. You've got your horizontal flow type, where water moves from one end to the other, kind of like a lazy river. And then you have the upflow type, which brings water in from the bottom and lets it rise up. But look, despite the different directions, the goal is exactly the same. Create a really calm, controlled space where gravity can just pull all that gunk down to the bottom. A clarifier isn't just some big, empty tub. Oh no. It's a carefully designed machine with 4 distinct zones. First up is the inlet zone, which is all about slowing the water down and spreading it out evenly. Then it flows into the main event, the settling zone. This is where those particles begin their slow journey downwards. As they fall, they collect in the sludge zone at the very bottom. And finally, the much cleaner water gracefully exits through the outlet zone up at the top. Inside that settling zone, every single particle is basically in a race. You've got the water trying to push it forward toward the exit, but at the same time, you've got gravity pulling it straight down. So for a particle to be successfully removed, it's got to hit the floor of that tank before it gets swept out with the clean water. It really is as simple as that. And this right here leads to one of the most surprising, kind of counterintuitive principles in all of water treatment. You would think a deeper tank would work better, right? I mean, it gives particles more room to fall. But the physics says nope. Removal has nothing to do with depth. What really matters, the secret ingredient, is the surface area. A wider, larger surface slows that forward flow of water way down, giving gravity more time to win the race for every single particle. Now, it also turns out that not all particles play by the same rules. Depending on what they are and how many of them there are, they can settle in very different ways. And engineers have grouped this behavior into 4 distinct classes. So you have Class 1, or discrete settling. Think of individual grains of sand just falling on their own. Then, Class 2 is flocculent settling. This is where particles start to clump together as they fall, getting bigger and heavier and settling faster. Then you get zone settling. This happens when the particle concentration is so high that they all settle together as one big mass, like a blanket. And finally, there's compression settling. That's what happens at the very bottom, in the sludge zone, as all those collected particles get squeezed together by their own weight. And here you can really see that difference in action. On the left, you've got those individual discrete particles, each one falling at its own speed. But check out the right side. That's zone settling. The concentration of particles is so high they've stopped acting like individuals. Instead, they're moving together as a single unified blanket, creating this really sharp, clear line between the sludge and the clean water up top. Okay, so now that we get the core idea that surface area is king, we can see how engineers took that concept and just ran with it. They started asking the big question: how can we improve on this basic basin design to squeeze more performance out of a much, much smaller space? And there was a very real, very practical reason for asking this. Your traditional clarifiers, because they need all that surface area, they take up a huge amount of land. And if you're a growing city or you're trying to upgrade an existing treatment plant, You can't just keep buying up more and more real estate. It's just not practical. This question really gets to the heart of the engineering challenge. How in the world do you get a massive amount of settling surface area without a massive footprint? Well, the answer isn't to build outwards, it's to build upwards. And this is the ingenious solution. It's called a plate settler, or in this case, a lamella separator. By stacking a whole series of inclined plates inside the tank, you just dramatically multiply the total surface area available for settling. It's like a multi-story parking garage for sediment. A particle doesn't have to fall all the way to the bottom of the tank anymore. It just has to fall a few inches and land on the nearest plate. And the advantages here are just huge. I mean, you get way more surface area in the exact same footprint, which makes it a super cost-effective way to upgrade an existing plant. It needs less land, obviously, and because the plates are inclined, usually somewhere between 45 and 60 degrees, the sludge that collects on them conveniently slides right down on its own for easy collection. It's a win-win-win. But that's not the only trick up our sleeve. There's another clever design that takes a totally different approach. It's called the Sludge Blanket Clarifier. And here's the cool part. The water is intentionally directed upwards through the blanket of sludge that's already settled. That sludge layer then acts like a natural filter, grabbing onto all the smaller particles as the water passes through. It's basically using the waste to clean the water.
But of course, no technology is perfect. This design is simple to operate, it's cheap, and it's fantastic for really cloudy water, but it does have its trade-offs. It can take a while to get that blanket started, and you need a skilled operator to run it. See, keeping that sludge blanket perfectly suspended is a really delicate balancing act. If the flow is too high, it breaks apart, too low, and the whole thing clogs up.
So, after looking at everything from these basic basins to the high-tech plate settlers, what is the one single most important thing to remember? Well, it really all comes back to that one core principle we talked about. If you want to make sedimentation more efficient, you don't dig deeper, you spread out. It's that simple. And whether you do that with a giant plot of land or with a bunch of cleverly engineered inclined plates, the goal is always the same. Maximize that surface area and give gravity the absolute best chance to work its magic.
And there you have it. That's how we use the most basic force in the universe to literally pull the dirt right out of our water. But remember, this is just step one. Sedimentation is fantastic at removing the things that are heavy enough to sink. But what about all the stuff it leaves behind? The dissolved chemicals, the bacteria, the viruses, the invisible threats? Well, that's where the next stages of water treatment come in.